In this practice, we're going to utilize limiting reagent and percent yield in order to find the percent yield for this problem. So I have sulfur and dioxygen, and they're just reacting to make SO2. I put 17 grams of sulfur in, I put 16.95 grams of dioxygen in, and I obtain 32.7 grams of our product. What I want to know is the percent yield for this reaction. How good a percent yield did we obtain? So go ahead, pause here, puzzle this out for a little bit. How are you going to factor in limiting reagent in order to calculate this? Give it a shot and then come on back. All right, if you're back, well, percent yield says I need to know my actual over my theory times 100%. I have my actual that was given to us. We were told we obtained this, so this is the actual product. 32.7 grams. What I need is the theoretical max. What was the max product I could make? Well, normally you take your reagent and you do your stoichiometry to convert grams of one compound into grams of another. However, in this case, I have 2 weights of starting materials. One of them will not be enough, so one of them is limiting. My first step is I must determine limiting reagent. So find limiting. To do that, I take both of my chemicals, so 17 grams of sulfur, 16.95 grams of dioxygen, and I convert them. I'm going to convert them into grams of my product. So I need to get out of grams of the chemical and into moles of the chemical. For sulfur, there is 32.06 grams in 1 mole of sulfur. I then need to get out of moles of sulfur and into moles of product. Well, the balance reaction was 1 to 1. If we go back and look, it is 1 sulfur for 1 SO2. In fact, it's also for 1 dioxygen. It's a 1-to-1 ratio. Well, finally, I want to be able to compare masses when I do my percent yield, so I need to get out of mole of SO2 and into grams of SO2. And 1 mole of SO2 is 64.06 grams. I'm going to do the same for the dioxygen. It is 32.00 grams of O2 in every 1 mole of O2. It is 1 mole of O2 for every 1 mole of SO2. And 1 mole SO2 is 64.06 grams of SO2. And so we can calculate what mass of product each of these starting materials could produce. That'll give us 33.968 grams SO2 from the sulfur. That'll give us 33.932 grams from the dioxygen. Well, if we compare, that's not quite as much weight from dioxygen. I will not make quite as much product from my dioxygen, SO2 there, as I made from my sulfur. So there's a little bit of extra sulfur in this mix. This means my O2, this is my limiting. Dioxygen is my limiting reagent, and this is the max possible SO2. Well, we were told there was 32.7 grams. So the actual was 32.7 grams of SO2. And the theoretical maximum is what our limiting reagent can make, 33.932 grams of SO2. So So my actual is a little less than my possible. 32.7 divided by 33.932. 96.369%. And we had sig fig wise, we were limited to 3 from our actual. So because we went with limiting reagent, we had 4, we had 4, we had 4, would have kept 4, but my actual only had 3, so we'll get 3 sig figs. 96.4%. So the yield we obtained on this reaction was only 96.4%. It required us to find two things. It required us to find the max possible, the theoretical max. But to do that, we had to find the limiting reagent, because what theoretical max we would have to use was the one the limiting reagent gave us, because you can only actually make as much product as your limiting reagent allows.